Good morning to one and all. I am Parthiban, working as Assistant Professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called Electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. Now I am going to talk about the Zener diode. What is the specialty of Zener diode, how it is working, and what are the advantages of Zener diode that we are going to see now. Zener is a one, which is a very special diode, particularly designed for reverse bias application, which is an heavily doped diode, unlike an ordinary PN junction diode, which is normally used in the forward bias direction. Zener is always intended to operate in reverse bias under safe conditions. The applied reverse voltage reaches a particular value known as the Zener voltage, that is denoted by the notation VZ. This voltage is also called as breakdown voltage or peak inverse voltage in the Zener application. The common Zener voltage values ranges from approximately 1.8 volts to 200 volts. Zener diodes are widely used for voltage regulation purpose and protection circuits. Zener diode as a regulator is a famous one. Now we are going to see about the construction and working principle of Zener diode. A Zener diode, as I already told you, is a heavily doped PN junction diode. Because of this heavy doping, the Zener region, that is, the depletion region, is formed at the junction, which is of very thin in nature. In the forward bias, the Zener diode behaves as if like a normal diode and allows the current to flow in the forward direction. However, the main purpose of Zener is to operate in the reverse bias only. When connected in reverse direction, the applied reverse voltage exceeds the Zener voltage. The diode conducts heavily without being damaged, provided the current is limited properly. This ability to safety operating in the breakdown region distinguishes the Zener diode from the ordinary diode. Since the depletion region is very thin in nature, the electric field across the junction becomes very strong even at a relatively low reverse voltages. So these are the important prime factors why we go for Zener as a regulator. The region, the Zener region and the reverse characteristics. In the reverse bias, a small reverse saturation current initially flows due to minority carriers. This current is almost independent of the applied voltage and remains very small in nature. As the reverse voltage is increased further and reaches the breakdown voltage, the junction breaks down and the reverse current increases abruptly. If current is not limited, the large current can destroy the ordinary diode. However, Zener diode is specifically designed to withstand this breakdown region safely. The breakdown voltage depends on the width of the depletion region, which in turn depends on the doping level of the impurity concentration. The more heavily doped diode, the lower will be the breakdown voltage. Now next we will see about the average AC resistance and how it is going to be calculated. Generally, there are two main breakdown mechanisms that happens in a PN junction. One is called avalanche breakdown, the other one is called Zener breakdown. In the lightly doped diodes, the depletion region is very wide. When the reverse bias is increased, the minority carriers gain sufficient energy and collide with the atoms in the lattice, generating additional electron volt pairs. This process multiplies rapidly and results in the avalanche breakdown. But in the heavily doped diodes, the depletion region is very thin. When the reverse bias voltage is applied, a very strong electric field is developed across the depletion region. This intense electric field breaks the covalent bond directly and generate lots of number of charge carriers around the junction. This mechanism is called a Zener breakdown. The Zener breakdown normally occurs at lower voltages, whereas the avalanche breakdown occurs at higher voltages. The minority carrier movement in reverse bias we have to see in a lightly doped PN junction diode under reverse bias condition. The depletion region is large The minority carriers, such as electrons in the p region and holes in the n region, move towards the junction due to the applied reverse bias. As the reverse voltage increases, these minority carriers gain more kinetic energy. When they gain sufficient energy, they collide with the atoms in the crystal lattice and break down the covalent bonds, producing a new electron hole burst. This multiplication process increases very rapidly and leads to breakdown. In xenodiodes, due to heavy doping and thin depletion layer, the breakdown mechanism is mainly due to the strong electric field under the thin applied voltage conditions rather than collision multiplication in nature. In the next, we are going to compare about the xenodiode versus ordinary diode, both as a regulator as well as about the characteristics. So one of the important applications of xenodiode is as a voltage regulator. When connected in reverse bias across a load, the xenodiode maintains a constant output voltage that is equal to its zener voltage, even if the input voltage or load current varies. This happens because in the breakdown region, a large current results in not only a very small change in voltage. Therefore, the xenodiode acts as a voltage stabilizer by connecting a suitable series resistor to limit the current. The Zener diode can safely maintain a constant voltage across the loop. Then we are going to see about what are the advantages of Zener diode as well as what are the properties of Zener diode. Zener diodes are simple, reliable, and inexpensive voltage regulators. They are widely used as power supplies. Because of the precise breakdown, they are used in the measurement and calibration equipment. Then we are going to see about the topic called a varactor diode, which is also called as a variable capacitance diode in nature. It is a PN junction diode whose capacitance is varied by means of varying the reverse bias voltage. The term varactor diode is originated from the variable capacitance. It is also a special diode which is used under the reverse bias condition, which is also called as varicap diode or tuning diode or variable reactance diode or variable capacitance diode. So the basic working principle is designed to store the electric charge and not to conduct the electric current. So the varactor diode should always be operated in the reverse bias only. So when reverse bias, the electrons move from the N region and holes move from the P region, both moves away from the junction. As a result of this, the depletion region width increases as well as the capacitance decreases since it is acting as a parallel plate capacitance. The capacitance is inversely proportional to the width of the region since it is a parallel plate capacitance of nature. C is equal to epsilon naught epsilon R into A by D. So we are relying on that formula to study the working principle of this varactor diode capacitor. The capacitance decreases as the width of the depletion region increases in nature. Generally, the VI characteristics of varactor diode can be discussed here. The width of the depletion region, if further increases, then the capacitance is further decreases. You see in the x-axis, there is a reverse voltage that is applied. In the y-axis, there is the capacitance that was produced. So if you increase the reverse bias voltage, then the capacitance is gaining high and so you see the decrease in capacitance means of decrease in charge also, storing charge also. So the reverse bias should be kept at a minimum to achieve a large storage. Generally, the advantages of varactor diode lies with its low noise and very compact in size as well as light in weight, more reliable and low cost. It can be covered for a wide range of frequencies. The specific disadvantage is it is specially designed only in the reverse bias condition, which cannot be used in the other conditions. So these are some of the prominent applications of varactor diode. It can be used for AFC, that is nothing but the automatic frequency controllers. It can be used in amplifiers. It can be used in HF radios, that is high frequency radio. It can be used in the frequency multipliers also, as well as it can be used for FM radio as well as TV receivers. These are the primary applications of varactor diode in nature. The references that I have made can be listed here. You can see from the various books that I have referred for this particular subject. Thanking you one and all for patiently hearing my lecture.